Radhe Radhe everyone. So I hope everyone is doing fine. It's taking a little bit of time to load the chat. Till then we can start with the video actually, but I'll still wait for a few people to join at least. Okay. Mm, Let me put it on Discord. Okay. So I think things are well tuned. You guys can see the chat. My streaming is not at all lagging and everything is fine. Great. Let's start. Let's start with. Yeah, I was watching Netflix. Okay, so let's start with the first question. The first question is maximize expression of three elements. You're given an integer array nums. You have to choose any three elements from the nums at distinct indices such that the value of the expression a plus b minus c is maximized. You have to return an integer denoting the maximum possible value of this expression. This is a very simple question. A very simple question. You are having an array and there are a lot of elements in it. You can choose any three elements A, B, and C such that A plus B minus C is maximized. Okay? So you have to find this. So if we do the differentiation, you know what it is. Uh, Differentiating on it, this, let's say this is sum. You know how to find it. It is just you have to make ds of dA and ds of dB and like that. Okay, ds of dA, ds of dB. So ds of dA is 1, ds of dB is also 1, and ds of dC is minus 1. So 1 means you have to maximize this, 1 means you have to maximize this, minus 1 means you have to minimize this. This could have been easily seen by the question also, not an issue, but the differentiation makes me clear for it. Okay, so since it's 1 1 minus 1, it means that this thing, it has to be reduced. So if this has to be reduced, we can take C as the smallest number possible. Okay, smallest. And for A and B, we have to find the largest and second largest. So first and second. So how to do that? It's very simple. Sort the whole array and A is the largest number, that is n minus 1, B is the second largest number, n minus 2, and C is the smallest number. You get the answer. Okay, very simple question, not much of thinking is needed in this. I am assuming that you guys can hear me. Let me just check once. Problem 4, any standard technique or just simple approach? Problem 4, it is like you have to understand a little bit. A similar kind of question appeared a few weeks ago. I am seeing that people have made the solution by using Fenwick tree. I was attempting for a binary search algorithm only. I couldn't do it because of the array index out of bound. Those things were coming, so I had to find the edge cases out. So I couldn't get the edge cases out yet. So the question is not yet submitted. I mean, it is partially solved, but I'll explain you. Okay, how to do that. It's just the time constant that I haven't done this. Okay, let's go to the second question. The second question is minimum string length after balance removals. You are given a string S consisting only of characters A and B. You are allowed to repeatedly remove any substring where the number of A and number of B is same. After each removal, the remaining part of the string are concatenated together without gaps. Return an integer denoting the minimum possible length of string after performing any number of operations. A substring is a contiguous, non-empty sequence of characters within a string. Okay. See, this question, first of all, I'll explain the answer and then I'll tell the proof of it. What I'm doing is I'm finding the number of A's in it and the number of B's in it, and the absolute difference is the answer. How? Let's say you're having a lot of A's in it, okay? Or you're having a lot of A's in it. And between those A's, there are few B's in it. Okay. Correct? Now, if you look into one thing, every B is at least paired with one A. Correct? And if it is not paired, it is difficult to remove it. Clear? So you can remove this. Don't think of that number of B is equal to number of A. Just think of it like uh, you're going to remove occurrence of AB and BA. Simply think like that, okay? So you can remove this, you can remove this, you can remove this, you can remove this. So what is left? Only 1A, because this 1A can't be paired with any B. In simple terms, you have to find the number of A's that can't be paired with B or the number of B's that can't be paired with A. Correct? But in more simpler terms, I am just telling you that it is the absolute value of number of B's is 3-digit DP. Yeah, it is digit DP. And the number of A's. Okay, this is what I'm telling you about the solution. Why? Because it is very simple to understand that for every, no matter whatever the string is, okay, let's say if you are having a, and all of them are A, and there is at least one B, you can remove it with one A, correct? Let's say there are 4 B's in between like this. First and second are easy, correct, correct. 4 B's in between. So you can remove it, and now this B is also linked to another A, right? So you can also remove it. So simply, no matter whatever you do, it's the number of B minus number of A's absolute value. Okay. What you can do is, for simpler calculation, you can take answer, and if there's a A, make answer plus plus, which is a B minus minus, and then return mat.abs answer. Okay. This is also a very simple question. Let's move on to the third question. The third question is count distinct integers after removing zeros. Okay. This is a good question. You're given, I did it with stack. Oh, you did this in the stack. Not needed only. You can do it. The exact thing that I was explaining, that there is a B and A and you can go on doing it like that. But it is not needed because you know what, like in the stack, let's say in the stack, it is never possible that you're having both A and B. Correct? Because in the stack, if you're having a A and then you put a B, this A gets cancelled out. Correct? So in the stack, the remaining part of the stack, it will be either all A's or all B's. Correct? So that's the reason you don't have to use the stack also. It was a very simple. But if there would have been like A, B, C, then you would have needed a stack. Obviously. Okay, great. Let's move on to the next question. You're given a positive integer. Okay, let me start from the beginning. The third question is count distinct integers after removing zeros. You're given a positive integer n. For every integer x from 1 to n, we write down the integer often by removing all zeros from the decimal representation. Return an integer denoting the number of distinct integers written down. Which means from 1 to n, you are going to write all the elements, but whenever you find a number which is having zeros in it, you are going to ignore zeros. Okay, so let's say from 1 to 11 I am writing, n is 11, okay. So 1, 2, 3, and you go on writing it, then 9, and after 9, you write 10, right? And then you write 11, right? But you can't write 10, okay. You can't write 10, you have to write it as 1 because you don't know how to write zeros. So this one, if you notice one thing, basically this one is something that has occurred earlier also. So it is no more a distinct element. Okay. So basically in this question, if we make the language of the question more better, it is telling us you have to find the number of integers from 1 to n which is having no zeros in it. Okay, which is having no zeros in it. How to do that? It's a simple question of permutation combination that you can check, but a little bit on the higher end, it is a DP. Okay, how many zeros are in numbers? No, that won't work now because the value of n is 10 to the 15. So you have to go on like, let's say you're having the value of n as something. Okay, so the first digit is this, the second digit is this, third digit is this, fourth digit is this, fifth digit is this, somewhat like that. Okay, so you're having this. These are just symbols, okay, just to denote the numbers. This is not one actually. Let me write it as something else. So this, okay. So these numbers are there, let's say, okay. Now that you know the numbers, so you can, in this position, what you can put is, let's say this number is k, okay. So in this position, you can put any number from 0 to k, right? 0 to k. Now let's say this number is L. Okay. So in this position, you can put any number from 0 to L, right? No, not always. That depends upon the fact that if in this position you're putting it as K, then you have to move on to this condition. But if you're putting it as, where did you earn? You earn matlab? Achha, learn digit DP. No, it's from contest only. Like I give contest and sometimes when the questions are like that, I get. But if it is from 0 to k minus 1, it gives us the freedom to choose anything we feel like. Okay. For 0 to k minus 1, you can choose from 0 to 9. This digit can be 0 to 9. You don't have to even think of it till L. Okay. You can choose anything from 0 to 9. Okay. And once this thing has been broken, this condition has been broken, throughout the all the numbers, you can choose 0 to 9. Okay. You don't need to choose anything else. But till this condition is going on, like first you take K, then you take L, then let's say this is M, then you take also M, then this is N. Now let's say in N you won't take N, you take N minus 1. So again from here you can go for 0 to 9. Okay. If this thing is getting a little bit complex for you to understand, I can explain it with an example. Let's say you're having 5241. Okay, this is a number, correct? So all the numbers which are less than this, I can write it as 0, 1, 2, 3, 4, 5. Correct? Now for 0, these things, it can be from 0 to n 9, right? 0 to 9. Any number you put. Okay. The same for all of them. Same for all of them. All these are same. But for 5, you can't put 5 over here because 5, 5, even if you put 0, 0, then also it is greater than 5241. So for this, you have to put anything 0, 1 or 2. That is a number between 0 to 2, right? Now let's say for this 5, you're putting 0. For this 5, you're putting 1. And for this 5, you're putting 2. Correct. Less than equal to 2. Now for this 5 that you're putting 0, after this, if it is 0, then it can be from 9 also. It can be 9 also. It can be 8 also. Correct? It can be 7 also. It doesn't need to be less than equal to 4. But since there is a 2 over here, so now it has to be less than equal to 4. Okay, you're getting it? So once this thing is violated, it is violated. You can choose anything towards it, right? Okay. So one thing in the DP you would need is a flag. Okay, I also forgot how I made the DP. I think the DP was current prefix flag. Okay, you need a prefix for this. Okay, this is a prefix flag. This flag is something else. I'll explain what this is. I'm really bad with naming of variables during CP contest. In real life, I think this is what I did in recursion, but I wasn't able. Just use memoization. Just use memoization. It works because after all, it is the number of digits, right? So that is 15 only. So 15 is well within our limit if you memorize it. And 15 into, let's say 15 into 10, 150. So 150 is a limit where you have to memorize, and if you memorize it, it's well and good enough. We can go with it. Okay. So this prefix is the flag such that till now, whether it has been tight with it, we are tight. Usually, like if you look into other solutions, the standard ones, they don't use prefix, they use tight. The word tight they use, which means that we are tight with the constants. If we are tight with the constants, so we have to be tight with the constants. But the moment we lose the tightness, we are okay to go with anything that we feel like. Okay, simple one. So this is for the tight. This flag is for the things that the number has started already. Okay, how do I know the number has started already? So let's say this is 0, and then I could have also taken 0, right? So 0 0 means the number hasn't started because I can't consider 0 0 zeros. Correct? So the number hasn't started yet. So this is the reason I need to check the number has started or not. Because only if the number has started, then only we are going to consider that 0 as a part of that number. Let's say you're having 0011. Correct? This is also a valid number. And if you look into this, there are two zeros in it, which means that it is not the thing that we are looking for, right? But it is the thing that we are looking for because the zeros are what to say, the the opposite of trailing, leading, yeah, leading zeros. So these are leading zeros. They don't contribute to the solution. Okay. So till there are zeros, we are not going to make this flag as one. Okay. Till there are zeros, we are going to make it zero. And once we get a number which is not zero, we make it one. Tight, I just told you what it is. So pre-flag and what was the other? I think that would be the current position, if I'm not wrong. Yeah, current position. The current position. So what is the current position? The current position is nothing but the position that you are pointing to. That is, first of all, you will be pointing to this 5, then this 2. So this position, that is the current position. Now, since you got the basic logic of it, I'll explain how the code has been written. First of all, yeah, you have to convert the number into a string, otherwise it is difficult for us to do the operation. Third was very standard digit DP, just don't consider 0. Correct, correct, correct. So DP of this, nn plus 1, 2, 2, 0, 1, 0. So why 0, 1, 0? 0 is the current position, that is we start from the 0th position. Flag is 0, I told you, we don't set it as 1 until unless we encounter a non-zero element. And pre is the tight value. So initially the value is tight. Okay. Initially whatever you do, the value is tight. If you find that the current is equal to n, that means you have already traversed all the elements. So you can directly return the flag. Okay. Why the flag? Because flag is going to return 0 if it hasn't been started yet. If it has been started, it is going to return 1. So it is going to consider one element. And if it hasn't started, it won't consider 0. Okay, that is for 0 0 0 0 0. Clear? Now, if DP of current and prefix, if we have already encountered this earlier, okay, then we can return it. If we have not encountered it, we have to calculate it. Okay, how do we calculate it? Answer is equal to 0. Now, m is nothing but the limit. I just told you that if some people solve it using combinatory, this is also combinations only. This is also permutation combination only. Just a little bit algorithmic part of it. Okay, if you can solve it, that's great. So if it is already tight, okay, if it is already tight, then we have to put the limit as the last element only. Okay, that is if it is 5 and it is tight, so we have to consider from 0 to 5, correct? But if it is not tight anymore, okay, then we can consider from 0 to 9. We can consider any digit. Okay, so this is the limit. Now for all the limit, what we are going to do is we are going to check that if I is equal to 0, that means if the current place that I am at, it is 0 and flag is also 1. What does flag equal to 1 means? That the number has not started yet. So all of the leading zeros are there. And now also we are considering another 0. So this is something which we don't consider only. We don't need this only. So you can directly continue. Okay, you don't need this. If flag 1, and you have to go for flag 1 and pre 1. Okay, now what is flag 1? Flag 1 is, we remember, the new flag, the value of the new flag. So flag is whether the number has started or not. So if the number has started, then obviously flag 1 is 1, correct? And if the first element is not there, that is, sorry, not the first, if the number is not equal to, current element is not equal to 0, which means that we have got a non-zero digit. Okay, we have got a non-zero digit. So our main condition was that if we have a non-zero digit, we make it 1, right? So we make it 1. And what is pre 1? It is tightness. So if it is already tight and I am choosing it at the limit, okay, if I am choosing it at the limit, that is 5, if I am choosing 5, then it will be also tight. Then it will be tight throughout. Okay, I mean, for the next element also it will be tight. But if I'm not choosing 5, I'm choosing any number which is before 5, then we lose the tightness. Correct? We lose the tightness. So that is simple, I think, explanatory. Answer plus is equal to the function of the recursive function of current plus 1, that is the next element, the new pre, the new flag, S remains the same, DP remains the same, N remains the same. We have to return answer is equal to DP of current pre flag and return that. Okay. Any doubt on this? Any doubt on this question? Arpit, Uday, anyone any doubt on this question? What the heck is? Can you explain combinatoric solution to from the solution? See, the combinatorics part is the same thing. Okay, the whatever I have done, just the part that I'll explain with 5 4. What was the solution? 5 to 4 1. I am taking 5 4 1 2. Okay. See, in this part you can put 0 to 5, right? 0 to 5. So that is 4. That is from 0 to 4 you can take, and for the remaining ones you can take from 0 to 9, right? So that is there are 10 10 10, or I let me take a smaller number. Okay, this is a little bit difficult for you to understand. Let's say I am taking 541 only. Okay, I'm taking 541. So over here I can take 4 elements from 0 to, sorry, we can take 5 elements from 0 to 4, and then at this position we can take 0 to 9 and 0 to 9. Okay, but if we are taking only one element, that is this 5, okay, then we have to go on till 4, correct? So since it is 1 and 2, so we can ignore that. So for this 4, we are going to take 4 elements and then into 10. Okay, 4 into 10, and 1 is remaining, and this is for 1. Oh, sorry. My mistake. Sorry, my mistake. I made a mistake over here. Since you are taking all of them are not zeros, okay. So for 0, you have to put a different condition. No. I made a mistake. For 5, there for 0 there has to be a condition. For the remaining 4, there has to be a condition. And for 5, it has to be a condition, okay. So for 0, I am not going to consider first of all. For 4, it is 10 into 10, okay. Now for this 5, we can ignore this, okay. But since this is the 5, so now this can't be zeros, okay. This can't be zeros. So I have to consider this to be 3 into 10. No, I can't consider 10, no? I can't consider 10, I think. Yeah, I can't consider 10 also. I have to consider 9 only for 10. Because there is no zeros that can be possible. So 4 into 9 into 9, 3 into 9. And for the last part, we can consider 1. Okay. So that is 4 into 9 into 9 into 3 into 9 into 1. What is the answer for that? Let me use my calculator and check whether I am doing the correct thing or not. Okay. 9 plus 3 into 9 plus 1. It is 352. Is it 352? It's two less number. Oh, okay. Now that we are done with this, so for these zeros also we have to take something, right? So if it is 0, so in this place we can have two parts. Okay, so for the 0 we have to check also. That is, if the first one is 0, then there are two parts. The second one is also 0. The second one is not a number which is greater than from 0 to from 1 to 9. That is 8. So if it is 8, then it will be 8 into 9. Okay. If it is 0, then also then the next number will be 8. Okay. So basically this is 8 and this is 8 into 9. So what was my solution? 352 plus 8 plus 8 into 9. So it is 432. It's coming as 432. I'm not sure, so I'll check for 541 first. What the solution comes. We won't waste time on this, okay? If the solution is not coming. 432 is a little bit difficult to come, I think. I think I'm going wrong somewhere. Oh my god, it's 442 only. We are very close. We are really close, okay. So it is 4 into, okay, 1, 2, 3, 4, 4 into this. Okay, I forgot the 5 condition, no? I forgot the 5 condition. So for 5, it will be 1 into 3 into 9. Sorry, 1 into. No. I am considering the 5 condition. I'm going wrong somewhere, but I can't. I don't know where I'm going wrong. 4 into 9 into 9 plus 3 into 9 plus 1 plus 8 plus 8 into 9. I'm getting as 432, but I think I'm going wrong somewhere. So that is the combinated part. Okay. a little bit of mathematics is needed over there. I think there is a formula for getting the number of non-zero containing elements. No, over here also they are showing me. Okay. Okay, it is 9 to the power. It is showing us 9 to the power that. That makes sense. That is what we are doing only. Because if you look into this, 8 plus 8 into 9 is nothing but. Oh, okay. 9 into 9 is 81. We are still getting 432 only, not 442. Okay, not an issue. Not an issue. This is also tied. This is also tied. This is 1. 541. 42. Are you live solving or you solve? I solved using DP digit. So I was checking if we can solve it using combinatorics or not. We can solve it. So yeah. And if you're new to this channel, so I'll tell you that obviously you're not new because I have turned on subscribers mode, I think. So yeah, I have already discussed this solution, okay, earlier. This I have failed for few edge cases, okay. Not this. Don't check this one. So this like 0 and 1, this type of edge cases I have failed for. Otherwise, I'll just explain the logic, okay. So the fourth question is count stable subarrays. You're given an integer array nums. A subarray of nums is called stable if it contains no inversion, which means that it is in strictly non-decreasing order. Okay. You're also given 2D integer array queries, where for each query you're given L1 and Li and Ri, and you have to find the number of stable subarrays that lie within that segment. Return an integer array answer of length cube, where answer of I is the answer to the ith query. Okay. Which means, what is a stable subarray? What is a stable array, let's say, or rather a stable subarray only? It means that all the numbers are in non-decreasing order. That is, this number, it is lesser than equal to this number. It is lesser than equal to this number. It's lesser than equal to this number. This is lesser than equal to this number. Okay. This is what it means. Now, you have to find the number of such segments. Correct. Let's say we have a subarray like this. So no matter whichever subarray we take from this subarray, okay, this subarray is a new array. If we take any subarray, it is also having a non-decreasing order, right? So how many subarrays we can take from here? Yeah, I also use find research. So how many subarrays we can take from here? It is 2 to the power n minus 1, okay? Because that is the number of subarrays that we can take. 2 to the power n minus 1. Okay. Now the point is, we are given the queries, okay, and within that query we have to find. So let's say we have got a specific array, and in that array there are few elements, not a few elements, there are a lot of elements. Okay, now you start from the first position and you see that till over here it was in increasing order. Okay, then you again now if you go from here to here it is going decreasing. Okay, so you're not going to take that. Then again you start from here, you find that till over here it is in increasing order. You start from here till over here it is in increasing order, and this is in increasing order. Now there are few things that we have to check. If this and this are in increasing order, and I'm given the constraint that find the number of stable subarrays in this range, which means we have to count the contribution of this plus the contribution of this. Okay, that is nothing but 2 to the power 3 minus 1 plus 2 to the power 4 minus 1. That is the total number of stable subarrays within that limit. Okay. Now this is one condition. This is one case. What are the other cases that can happen? Okay. So first of all, let me just copy the cases. Okay. So let's start with the first case. The first case I've already explained. That is the beginning and ending. They are consisting of these greens. Okay. Green parts. What is the second case possible? It starts from somewhere over here and ends somewhere before this. Okay. Now the calculation of this is easy. The calculation of this is also easy. What was this? This was nothing but 2 to the power 4 minus 1. Correct? This was 2 to the power 1 minus 1. You just go on add them. Just go on adding them. And this is 2 to the power 2 minus 1. Correct? For this is going to contribute as 2 to the power 1 minus 1. But now, instead of contributing as 4, now it is going to contribute as 2 to the power 3 minus 1. Okay? And this is going to consider as 2 to the power 1 minus 1. Correct? Now what are the other test cases? The other test cases are the following. That is, what if it starts and ends at the same one? Okay? So that is also very simple. Just consider two of them. Correct? 2 to the power 2 minus 1. Any other test cases left? What if it starts and ends at the same element? This is the test case where I have been struggling. ठीक है. I haven't coded it yet. I have put a solution. Let's see what comes. I think it will be also wrong answer only because there are other test cases. Okay. Okay. It is also wrong answer. Great. Hello. क्या हाल है बताओ. Which part is binary search? Oh, अच्छा, which part? हाँ, I am telling. Just. One eight four five. Great. Great. So ये condition, this condition is very easy. You can just consider only one element. So it is going to be one element only. This condition is also easy. So all of them are somewhat easy. Okay. But the problem occurs when there is only one of them. You're having a array and all of the numbers are in increasing order. Then is the then is where the problem occurs. ठीक है. ये तो सॉल्व हो जाना चाहिए था भाई इधर. ये बोल रहे 1,2 है. दिल्ली दूर है अभी. क्यों भाई, क्या हो गया भाई, क्यों दिल्ली दूर है. तो दिस इज वेयर द मेन कंडीशन इज फेलिंग. ठीक है. बट डिड यू, अरे यार क्वेश्चन हट जाता नहीं अब, मुझे बहुत ये लगता है. सो डिड यू गेट द जिस्ट ऑफ द होल क्वेश्चन. इसमें क्या करना है, क्या बन रहा है ऐसे, मतलब व्हाट इज हैपनिंग इन दिस क्वेश्चन. डिड यू गेट इट. अरे यार मैं कंटिन्यू नहीं करा किया. शिट. मैं वही सोच रहा हूँ क्या गड़बड़ जा रहा है मेरा इधर. रुको, अब करके देखते हैं. चलो अभी भी रॉन्ग आंसर आ रहा है. 1 से 3. पर I still don't know how you will ensure to sum all these to the power n in log n. ओ, अरे हाँ यार, मैं मेन लॉजिक ही नहीं समझाया. सॉरी सॉरी, माय मिस्टेक, सॉरी. देखो व्हाट यू कैन डू इज, जब ये जो तुम्हारा ये बन रहा है ना ये एरे, हाँ, जो मेन पार्ट था जो मैं बनाया भी इधर. ठीक है, मैं समझाना भूल गया, मैं अपने टेस्ट केस पे थोड़ा उलझा हुआ था. देखो व्हेन यू आर मेकिंग दिस ना, यू कैन मेक इट लाइक द स्टार्टिंग पॉइंट. ठीक है, द स्टार्टिंग पॉइंट, the number of elements in it, and 2 to the power 3 minus 1, that is 7. ठीक, सॉरी 7. ठीक है. अब मेरा जब नेक्स्ट बनेगा, इट इज 0 1 2 3 4 5 6. ठीक है, सॉरी 1 2 3 4, करेक्ट. और इसका क्या बनेगा, 2 to the power 4 minus 1, 2 to the power 4 8 8 16 16 minus 1 15. ठीक है. and you can go on making this, ठीक है, like this. Now what you have to do is, ये जो पार्ट है, ये जो पार्ट है, इसको तुम प्रीफिक्स सम बना लो. Okay, so make this 15 as 15 plus 7, that is 15 plus 7 कितना होता है, 22 एंड सो ऑन. ठीक है, जो थर्ड पार्ट है उसका प्रीफिक्स सम बनाते जाओ. नाउ लेट्स से मुझे बस इतना निकालना है, इतने का. ठीक है, तो इसका प्रीफिक्स सम कैसे निकालूंगा, जो इसका थर्ड पोजीशन में होगा. ठीक है, -7, because that is going to be removed, correct. This is what is going to contribute as the answer, right. That is going to be removed and the remaining is what your answer is. Clear? हाँ, करेक्ट 22. थोड़ा लैग हो रहा है स्ट्रीम. ठीक है, तो this is what the answer is, right. But let's say if what we are going to consider is this. टिल ओवर हियर. ठीक है, चलो मैं थोड़ा ज्यादा डार्क कर दिया इसको. टिल ओवर हियर. तो इसको कैसे निकालेंगे, इट इज नथिंग बट दिस, द कंट्रीब्यूशन ऑफ दिस प्लस द कंट्रीब्यूशन ऑफ दीज टू एंड दिस वन, दैट इज इसका जो आएगा प्लस 2 to the power 2 minus 1 प्लस 2 to the power 1 minus 1. ठीक है, अब क्लियर है. और इसका मुझे कैसे निकालना है कि लेट्स से इफ आई एम हैविंग बाइनरी सर्च क्यों चाहिए, बिकॉज लेट्स से इफ आई एम हैविंग द फर्स्ट पोजीशन एज L एंड सेकंड पोजीशन एज R, तो मुझे बाइनरी सर्च में ये जो 0 3 ये सब सॉर्टेड है. ठीक है, इसमें जो मेरा आया आंसर, तो इसमें से मुझे निकालना है कि L जो है the first element which is greater than equal to L, that is 3, right. and इसमें निकालना है the first element जिसका ending that is 3 plus, इसका ending क्या होगा 3 plus 4 minus 1, इसका ending क्या होगा 0 plus 3 minus 1, because it is 0 1 2, right. the ending is 2, that is 0 plus 3 minus 1. for this the ending is 3 4 5 6, that is 3 plus 4 minus 1. ठीक है, तो starting plus length minus 1 is the ending, correct. तो उसका end, जिसका end is lesser than equal to R. ठीक है, जिसका end is lesser than equal to R, और इसमें ढूंढना जिसका starting is greater than equal to L. ठीक है, now is it clear क्यों मुझे चाहिए, and this is the smallest starting which is greater than equal to L and the largest ending which is lesser than equal to R. ठीक है, for this you need the binary search. I'll show you the code. Okay, देखो कोड में क्या करना है, अरे इधर से दिखा देता हूँ, बेस्ट है. देखो कोड कैसा चल रहा है मेरा. I'm having a start, I'm having a count, and for every position I'm checking कि भाई it is in descending order or not. To find starting and ending index of compute set. Correct. And then we are adding it start and count. ठीक है, if the condition is breaking, then we are adding at start and count and making start as I, the current position, and count as 1. That's because we are considering the current position. Otherwise count plus plus, that is we are going to make the count plus plus. Okay. At the end, add it to the list. This is NN, that is the length of the start part. Okay, we have to consider that. And if n is equal to list dot size, then we are having a DP में इसको ऐसे ही नाम दे दिया, इसका कोई मीनिंग नहीं बनता DP नाम देने का. ठीक है, तो DP of I of 0 is the start, I of 1 is count, and I of 2 is the calculation of the count, that is 2 to the power count minus 1. तो 2 to the power count minus 1. इसको अगर तुमको वो लिखना होता है 1 लेस देन वो क्या बोलते हैं उसको, लेफ्ट ऑपरेटर या फिर राइट ऑपरेटर, वो सब तुम कर सकते हो लेफ्ट शिफ्ट राइट शिफ्ट करके, not an issue. Then we are going to make it prefix sum, जो अभी बताया मैंने. ठीक है, डन विथ इट, आंसर मिल गया. A and B क्वेरी ऑफ I है. अब S करके क्या निकालोगे, बाइनरी सर्च करोगे ऑन DP A पे, एंड तुम दूसरा बाइनरी सर्च करोगे DP ऑन B पे. अब ये दोनों बाइनरी सर्च अलग अलग है, क्योंकि एक में यू हैव टू फाइंड द ग्रेटर देन इक्वल टू एंड दूसरे में यू हैव टू फाइंड द लेसर देन इक्वल टू. ओके, तो दैट इज द पॉइंट वेयर इट डिफर्स. पाव एचटीएल बड़े नंबर्स में सही नंबर दे रहा है. हाँ वही करेक्ट, दैट इज द थिंग. वही मैंने बोला ना कि ये मैंने गलती कर दिया, ये पाव नहीं डालना चाहिए था मुझे, क्योंकि दिस शुड हैव बीन लाइक लेफ्ट शिफ्ट एंड राइट शिफ्ट ऑपरेटर्स. आई शुड हैव यूज्ड दैट. माय मिस्टेक ऑन दैट. नाउ अब मैंने क्या किया कि अगर a is equal to b, that means only one element is there. Answer is equal to 1, continue. If n is equal to 1, मतलब only one segment is there, that is the whole array is only sorted. ठीक है. Then mat dot power 2 comma b minus 1, b minus a plus 1. ठीक है. That is the whole thing. You can take. Otherwise थोड़ा प्रॉब्लम होगा निकालने में. अब मेरा प्रॉब्लम ये हो रहा है कि तुमको देख के समझ में आ जाएगा कि जो केस है सब टेस्ट केस देख के समझ में आ जाएगा. देखो 21 3 4 17, तो ये कैसा होगा? 21 और 3 4 17 को मैं एक साथ पकड़ता हूँ. ठीक है. लेट्स से दिस इज 1 एंड 3 4 17 इज एक साथ. ठीक है. 3 4 17 बिकॉज दैट इज ऑलरेडी सॉर्टेड, राइट. ये दोनों अलग अलग. अब इसमें क्या बोल रहे हैं, ये मेरा टेस्ट केस क्या है? 1,3, दैट इज दिस पार्ट. अब इसका सोल्यूशन क्या होना चाहिए अकॉर्डिंग टू यू? व्हाट डू यू थिंक? द सोल्यूशन विल बी नथिंग बट 2 to the 3 minus 1, right? To the 4 to the 8 minus 1, that is 7, correct? अरे क्या बोल लो भाई, 7 ही तो होना चाहिए. एक्सपेक्टेड कैसे 6 है? Oh my god. How is it 6, man? Am I going on the wrong track anyhow? One comma 3 means 1 2 3. So 3 is a valid one, 4 is a valid one, 17 is a valid one. 3 बन गया. Then 3 4 and 4 17. I got more to 5. And 3 4 17. I got 6. One plus 2 plus 3. अरे shit man, shit. समझ में आ रहा है क्या होगा? गलती. It is, sorry, my mistake यार, my mistake guys. It's not 2 to the power n minus 1. ठीक है, my mistake. 2 to the power n minus 1 तब होता अगर वो subsequence होता. It is n into n plus 1 by 2. My mistake, sorry guys. It is going to be n into n plus 1 by 2. Shit man. देखो अगर मैं ये नहीं करता ना, तो मुझे लग रहा था कि मैं वही सोच रहा हूँ कि भाई मैं इतना ध्यान लगा के बनाया इस कोड को, हाउ कम दिस इज नॉट गेटिंग एक्सेप्टेड. ओ माय गॉड. अभी तो और प्रॉब्लम हो जाएगा क्योंकि इतना कुछ मैंने कर दिया कि मेरा दिमाग ही खराब हो चुका है. अब तो मेरा मन नहीं कर रहा अभी कोड करने का इसको. b minus a plus 1 है ना. Oh my god. Oh my goodness. Oh my friend, इतने साथ रहना साथ हमेशा. अगर इसके बाद नहीं होता तो मैं नहीं करूंगा, ठीक है. सॉरी गाइस, मैं नहीं करूंगा. अरे यार, पाव नहीं उठा. तो तब से सोच रहा हूँ भाई क्या गलती कर रहा हूँ मैं. नहीं बनेगा भाई, मैं क्विट मार दूंगा भाई, मैं नहीं कर सकता इतना. अच्छा आपसे चलो. कुछ ना कुछ तो एचपीएस फंसेगा भाई, देख के समझ में आ रहा है, कुछ ना कुछ तो फंसेगा. चलो फंस रहा है. इट इज फॉर 1,2. एक्सपेक्टेड इज 2, मेरा 3 आ रहा है क्योंकि आई एम डूइंग समथिंग रॉन्ग. ठीक है. एनीवेज लाइक वी गेट इट राइट. या फिर डिबग करना है, तुम लोगों के पास टाइम है डिबग करने का? अगर नहीं है तो बताओ, तो फिर ये कर देंगे, डायरेक्ट रेट करके छोड़ देंगे. अगर मन कर रहा है करने का तो कर सकते हैं. मुझे तो मजा आता है भाई, ये हार्ड क्वेश्चन कैसे अप्रोच करे. ये हार्ड क्वेश्चन बस अप्रोच करो यार, कुछ फर्क नहीं पड़ता. बस अप्रोच करते जाओ करते जाओ करते जाओ, एक दिन ऐसा लगेगा कि हार्ड चोरी है ये. नहीं यार, हार्ड होता है भाई, हार्ड होता है. करते हैं, चलो करते हैं यार. तो 1,2 में क्या आ रहा है? 23 और 3. ठीक है. तो इसमें s का वैल्यू आ रहा है 0, क्योंकि इट इज गोइंग टू बी 623 एंड 39. तो द वैल्यू फॉर विच 1,2 में प्रॉब्लम है ना. 1,2 में मेरा प्रिंट नहीं हो रहा, मतलब इधर तक आ ही नहीं रहा. तो आई एम पुटिंग इट समवेयर ओवर हियर ओनली डायरेक्टली. ना s is equal to e plus 1. नहीं, ये भी रॉन्ग है. तो फिर मैं इधर तक क्यों नहीं आ रहा? या फिर पहले वाले में नहीं आ रहा शायद. 0,3, 0 1 2 3. बस इसी टेस्ट केस को पोस्टमार्टम करेंगे, ठीक है. बस इसी केस का पोस्टमार्टम करेंगे. इसको निकाल देते इधर से और इसको डालता हूँ मैं इधर पे. चल, लेट्स पोस्टमार्टम दिस. इसको एकदम छोटा कर देता हूँ. चल, फेल तो किया. अब देखते हैं क्यों फेल किया. 0 1 और 1 0. अच्छा, 0 1 is working fine, 1 0 is not working fine for us. तो 1 0 में क्या होगा? 1 मतलब वो शुरू होगा S1 से और ये 0 पे है। कंप्लीट सेगमेंट का आंसर सी आउट करके देखो, वहां एरर है क्या? कंप्लीट सेगमेंट्स का आंसर अच्छा हाँ सही बोल लो। बट अगर 0 1 आ रहा है ना, आई थिंक कि उसमें कोई इशू नहीं होगा शायद। 0 1 आ रहा है तो मतलब आई एम हैविंग अ फीलिंग, बट स्टिल करते हैं रुको। तो पहले इसको देखते हैं। तो ये है ऐसा 0 1 2 3, ठीक है। तो ये मेरा 1 है, ये मेरा 3 है। द फर्स्ट थिंग विच इज ग्रेटर देन इक्वल टू 1, वो क्या होना चाहिए? ये होना चाहिए। एस का वैल्यू क्या होना चाहिए? 1, करेक्ट। एस का वैल्यू क्या है? सॉरी, एस इज 1, हाँ। ई का वैल्यू क्या होना चाहिए? द फर्स्ट एलिमेंट विच इज लेसर देन दैट, ठीक है चलो। ओके 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 ओके। तो फर्स्ट ऑफ ऑल तो ये कंडीशन हटाना है अपने आप। ये प्रॉब्लम कर रहा है ये वाला कंडीशन, इसको हटा देते हैं। अभी अगर मुझे पता है कि ये जो है, मतलब एस इधर कहीं पे होगा, एस आइदर इधर पे होगा या फिर इधर पे होगा, ठीक है। और ई जो है अगर वो इसको पॉइंट कर रहा है तो आइदर वो यहाँ कहीं पे होगा या फिर इधर पे होगा। और वो इधर ही है और ये इधर है। तो ई का मुझे कैसे निकालना है? फर्स्ट थिंग तो ये है कि मुझे कंसिडर नहीं करना कुछ भी, ये वाला मुझे कंसिडर नहीं करना, ये वाला। अगर s माइनस 1 ग्रेटर देन इक्वल टू 0 है तो ये करूंगा, e ग्रेटर देन इक्वल टू 0 है तो ये करूंगा। अगर ये होगा तो मुझे ये कंसिडर नहीं करना फर्स्ट ऑफ ऑल, ठीक है। e इज इक्वल टू मैक्स e कॉमा s कर दो। क्या बोल रहे हो भाई? e इज इक्वल टू मैक्स e कॉमा s, e इज इक्वल टू शुड इट वॉक ना, फिर तो वो हो जाएगा ना, माइनस में आ जाएगा s के लिए। वी हैव टू मेक द कैलकुलेशन आल्सो लाइक दैट, ठीक है। बात तुम सही बोल रहे हो, कुछ गलत नहीं बोल रहे हो, सही बोल रहे हो। e को तुम मैक्स कर दोगे तो हो जाएगा, वो 1 हो जाएगा, ये 1 ये भी 1 हो जाएगा, करेक्ट। बट वैसे बनेगा नहीं क्वेश्चन ये जो कंडीशन है ना इसके लिए अलग से बनाना है। हाँ करेक्ट करेक्ट, उसी के मैं वही बोल रहा हूँ कि अगर e ग्रेटर देन e लेस देन इक्वल टू x होगा, सॉरी e लेस देन x होगा, s होगा, तो उसका अलग से बनाना है, मैं वही बोल रहा हूँ। बस ऐसी e का वैल्यू आना चाहिए। लेट्स सी ब्रो, एक मिनट रुको, हाँ। क्योंकि हम लोगों को ये कंसिडर करना है कि ये करने के बाद, ये जो हम लोग कर रहे हैं ना मैकेनिज्म, ये करने के बाद भी चीजें छेद नहीं जाना चाहिए। दैट इज व्हाट आई एम थिंकिंग। क्योंकि अगर मैं बोल रहा हूँ कि आई थिंक तुम्हारे बात में लॉजिक तो है भाई काफी तगड़ा। देखो एस का तो मैं सही पकड़ रहा हूँ, ठीक है। ई का मुझे चेक करना है। एंड आई एम हैविंग अ फीलिंग दिस में वो ना, मे बी लेटर टेस्ट केस फेल हो जाएंगे, ये शायद पास हो जाएगा बस। करेक्ट करेक्ट, वही मैं बोल रहा हूँ। तो उससे कुछ फायदा नहीं है ना हम लोगों को। वी हैव टू थिंक ऑफ इट कि सारे टेस्ट केस पास होना चाहिए। ये मैंने कुछ लगाया दिमाग इस पे, लेट्स सी। अभी कुछ और टेस्ट केस फेल हो रहा है ना। 0 1 2 3 4, तो 3 4 फेल हो रहा है। 1 2, एक काम करते हैं, ठीक है, सिंस वी नो एस, ठीक है, एस इज समथिंग जो उससे ज्यादा हो, करेक्ट, तो वी आर नॉट गोइंग टू कंसिडर एस इनडायरेक्टली, क्योंकि अगर दोनों सेम में आ रहा है ना, दोनों सेम में आ रहा है, देन अगर दोनों सेम में आ रहा है यार, वो कैसे निकालूं? मे बी लेटर ये वापस पीछे आ रहा है, इसमें भी ना ना, इसमें सब कुछ, हाँ ई वापस पीछे आ रहा है, सही बोल रहे हो तुम, करेक्ट करेक्ट, ई वापस पीछे आ रहा है। एस का वैल्यू क्या आएगा इस पे? एस विल बी एन, करेक्ट। हाँ 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 हाँ, I have a great idea in my mind, जो कि बस इस कंडीशन पे दिमाग लगाएगा। int I is equal to n minus 2, I greater than equal to 0, I minus minus, तो मैं n minus 2 से ग्रेटर देन तक जाऊंगा अगर मेरा नेक्स्ट एलिमेंट मेरे से बड़ा हो, इट इज ग्रेटर देन इक्वल टू nums of I। समझ लो, तो अगर दोनों सेम में है ना, तो वी वोंट कंसिडर ओनली, भाई उतना दिमाग ही नहीं लगाएंगे, डायरेक्ट ये कर देंगे। मेरे दिमाग में ये चल रहा है, कंसिडर नहीं करेंगे, डायरेक्ट ये बोल देंगे कि भाई ये आंसर है, तुम रख लो अपने पास। दिस इज व्हाट आई एम थिंकिंग करेंटली। लेट्स सी, फर्स्ट ऑफ ऑल इसको डाल के देखते हैं टेस्ट केस जा रहा है कि नहीं। ओके, कुछ ये गड़बड़ कर दिया था मैंने, हाँ गड़बड़ कर दिया है मैंने। गड़बड़ ये है कि इसको इधर नहीं डालना है, ये जो है इसको इधर नहीं डालना, इसको और ऊपर करना पर्टिकुलर, डायरेक्ट इधर कर देते हैं इसको। पांच टेस्ट केस तो पहले भी था ना, ये 923 वाला है या फिर कुछ और वाला टेस्ट केस है? नहीं ये नहीं आया, मुझे ये टेस्ट करना है भाई। हाँ, आई वांट टू टेस्ट दिस। वो तो ऑलरेडी पास कर रहा था भाई, उसका क्या फर्क पड़ता है। ओ भाई भाई इतना कितना गंदा दिमाग लगाया मैंने। अप्रोच अच्छा है, मैं भी इम्प्लीमेंट करूंगा अभी करना। भाई कितना गंदा दिमाग लगाया मैंने, एंड में जाके कितना छोटा सा एज केस में फंस रहा था ये। चलो, इट्स गुड, ऑल ऑफ देम आर डन। आज कितना एक है, कितना था आज? 1443 ना, बन जाता है मेरा भी। चलो कोई बात नहीं। सो लेट्स रेट द प्रॉब्लम्स क्विकली। मजा आया भाई? एक बात बताओ भाई, डिबगिंग करने में मजा आया? बिकॉज मुझे तो बहुत मजा आता है डिबगिंग करने में। 1.9, आई एम नॉट सेटिस्फाइड यार। ऑनेस्ट बताओ तो आई एम नॉट सेटिस्फाइड, क्योंकि आई वाज एक्सपेक्टिंग कि ये बन जाएगा मेरा डी वाला, ड्यूरिंग कॉन्टेस्ट ही बन जाएगा, बट इतना फालतू किया ना मैंने। अरे वो अगर मेरे दिमाग में आ जाता ना कि भाई वो n इंटू एन प्लस वन होगा, नॉट 2 टू द पावर n। मेरा थर्ड में डीपी में इंट यूज करने की वजह से दो। अरे भाई ये तो बहुत गंदा काटता है, ओवरलोडिंग। चलो यार हार्ड, ये मीडियम। अरे यार हार्ड और मीडियम सेम लग रहा है दिखने में। एच चाहिए, एच। ये है मीडियम। फर्स्ट दो क्वेश्चन इजी था, ठीक है। हाँ ये n इंटू एन प्लस वन और टू एन। करेक्ट 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 करेक्ट। अरे मेरे दिमाग में ना वो घूमता है ऑलवेज कि सब सीक्वेंस घूमता है। एक सिंपल चीज है, ठीक है, एक सिंपल सा फॉर्मूला है कि अगर सब सीक्वेंस होगा देन इट इज 2 की पावर n माइनस वन, और अगर सब एरे होगा देन इट इज n इंटू एन प्लस वन बाई टू। ठीक है, इन सिंपल वर्ड्स यही सीन है। तो दिस इज मीडियम ना। तो थर्ड सी वाज, सी को कितना रेटिंग दूं भाई? सी वाज कहाँ था सी? डिजिट डीपी था भाई, इट डिमांड्स ऑन अ दिस स्केल, और डी भी डिमांड्स ऑन दिस स्केल, बट जस्ट बिकॉज कि भाई सी बहुत ही बेसिक, हाँ भाई मैं बोल रहा हूँ सी बहुत ही बेसिक डीपी था, तो दिस इज ओके आई थिंक। और डी को थोड़ा तो रिस्पेक्ट देना चाहिए भाई, मेरा भी फटा है पुट करने में उसको, तो हाँ। बट डी आई can't put in hard, I can't never put in hard because hard questions are really difficult। डी देख के समझ में आ रहा है कि भाई ये बन सकता है क्वेश्चन, तो डी इज मीडियम हार्ड। सो दैट्स इट फ्रॉम माय एंड यार। हार्ड नहीं था, करेक्ट। दैट्स इट फ्रॉम माय एंड, थैंक यू गाइस फॉर ज्वाइनिंग। चलो मिलते हैं वैसे, आई थिंक नेक्स्ट संडे, हाँ नेक्स्ट संडे आई विल कम। आज आई सी इफ आई कैन सिट टू कोड द कोड फोर्सेस वन। अगर मैं कर देता हूँ कोड फोर्सेस वाला तो आई विल कम, मतलब अगर मैं बैठता हूँ तो मैं आऊंगा, बट अदरवाइज लाइक संडेज आई फील लाइक रेस्टिंग अ लॉट, ठीक है। सुबह वाला इट्स ओके, चलो 8 बजे एटलीस्ट लीड कोड कर रहा हो तो वो अच्छा भी लगता है। बट कोड फोर्सेस का वो है ना कि अगर कोड फोर्सेस में 4 क्वेश्चन बने तो ओके है, बट उसमें रहता ही बहुत सारे क्वेश्चन, तो वो प्रेशर भी रहता है चीज़ों का। तो अभी मेरा वो नहीं होता, अभी ज़्यादा प्रेशर पे कोड नहीं कर सकता मैं ज़्यादा, अभी बस आई एम डूइंग इट फॉर फन। तो दैट्स इट, चलो यार गाइस, चलो बाय, मिलते हैं नेक्स्ट वीडियो पे।